Hi, this is Saranya Chejarla. Welcome to Easy BTech. Now we are going to discuss about an Arpanet and Internet in computer networks. So let us get into the topic. Arpanet. Arpanet was started by Paul Barron in 1960s, funded by Advanced Research Projects Agency (ARPA), an organization of the United States Defense Department. Therefore, it was named as Advanced Research Project Agency Network, ARPANET, which is called an modern internet. See, this concept, this is a topic we little bit introduced in TCP/IP reference model. Let us deeply discuss about what is meant by ARPANET. Okay, it was world's first fully operational packet switching computer network. Fully operational packet switching computer network. Packet switching computer network means there is a connection between one device to another device without using an telephone lines. Okay, there is a connection between one device to another device to communicate data without using telephone lines, and the world's first successful computer network to implement the TCP/IP reference model that was used earlier by ARPANET. I already said in the previous session TCP/IP reference model. So the TCP/IP reference model was introduced in 1960, but it comes into the internet in 1990s. At that time, it worked in the ARPANET. Okay, so just remember that point before being used in the internet. Okay, so what is meant by the packet switching computer network? What is the concept of packet switching? So let us discuss about an packet switching here. Okay, so I will show the diagram how the data will be transmitted from one device to the or one computer to another computer in the network using packet switching. Okay, so this is a diagram. Look at that. So this is a packet switching, and here this is a device A, B, C, D that connected to the network, and we are using this red dots or routers. Red dots or routers. So from A, I'm delivering and 4 packets, 1, 2, 3, 4 packets to a network. So by using this router, each and every packet will send a different route or a best route to the particular destination. So A is the source and D is the destination. We have to communicate data from A to D through the network. See, we have a different type of routers in the middle of the network, and we have a different type of routes to send the packets by using a particular route or best route to the destination. Okay, see this is the packet 3 and 1 or delivering in a one route, and packet 4 is delivering in another route, and packet 1 is also delivering to another route. So like this, in the whole network from the routers, it finds an best route and it goes to the destination. This is the packet switching concept, and there is no telephone line concept in this model. We are not using telephone line concept. Okay, so this is the ARPANET is the first world packet switching computer network. Old first packet switching computer network. It follows that to communicate data from source to destination. Okay. See, ARPANET was built to accommodate research equipment on packet switching technology and to allow research sharing for the Department of Defense contractors. So mainly the ARPANET was introduced for research equipment, means scientist generation. Within that only it provides a packet switching technology to allow the resource sharing only for Department of Defense contractors. What are the contractors are there for this type of Department of Defense? For that sake, the ARPANET was built to allow the resource sharing. Okay, the network interconnected research centers, some military bases and government locations. It soon become popular with researchers for collaboration through electronic mail and other services. See, the network interconnected research centers. So what are the research centers we have? This network will be connected by that research centers. So it's mainly used for an military and government locations, military bases and government locations. It soon become popular with researchers for collaboration through transferring the email and other services. It is basically a WAN. We know that WAN is one type of network. See, what is meant by WAN? What is meant by WAN? See, so it is a group of LANs. It is a group of LANs and MANs. It is a group of LANs and MANs. So within one country we are providing a network, we can call it as an WAN. Within one country we provide a network is nothing but an WAN, and it is a group of LANs and MANs. It is a group of LANs and MANs. So literally we are telling about that ARPANET is basically a WAN. Before ARPANET, the networks were basically the telephone networks which operated on the circuit switching principle. ARPANET used the concept of packet switching network consisting of subnet and host computers. Circuit switching concept means what? See, I already said in the previous classes, by using an telephone lines, we can the particular devices connected to the telephone lines. So I am drawing here. See this. This is one device. This is another device. Okay. So I'm connecting these devices to telephone lines. So these are the telephone lines. Okay. So by using these telephone lines, we are transferring data from source to the destination. So to convert this data, we use an modem concept here. It is one of the communication device that transfers the data from one device to another device. So in telephone lines, from one system, it will be in digital format, sent to the modem in digital format. Again, the modem will be converted into analog waves to the remote area systems. Okay, so this is a circuit switching concept, which means we are using an telephone lines concept for network, that is nothing but an circuit switching. So to eliminate that, the ARPANET is the ARPANET coming to the new technology is nothing but an packet switching. New technology is nothing but an packet switching, and here the packet switching concept is the networking consists of subnet and host computers. See, the software for ARPANET was split into two parts, namely subnet and host. So let us see what is meant by subnet and what is the host. The subnet was a datagram subnet, and each subnet consists of mini computers. We can call it as interface message processor. we can call it as interface message processor. Each node of the network used to have an IMP and a host connected by a short wire. Short wire. See, let us see the diagram. We can easily understand how the computers are connected to one IMP. What we call this is a particular subnet. Okay, see, let us see the diagram here. So this is the actual diagram. Here, this is an host. Host means users. And these are the IMPs, which connects a mini computers. Okay. So one IMP means a device. IMP means a device or a node or a computer. Device or a node or a computer. Okay, so each and every host connected to this particular IMP by using an protocol. Here it is, we got a protocol concept, means we use an TCP IP reference model. Okay, so this is a collection of these particular IMPs we can call as an subnet. We can call as an subnet C. The combination of all these IMPs. Okay, so we can connect this particular IMP by using an IMP protocol. We use an IMP protocol. Okay, IMP protocol. By using this protocol, we connect each and every IMP, and the host is connected through a short wire to that particular IMP. So this combination of combine these all IMPs, we can call it as an subnet. So here the mainly Arpanet is split into two types, nothing but an host means the user, and the host and subnet. Host and subnet. Host and subnet. So in diagram we clearly see that what is meant by host and what is the IMP we have. We can connect each and every IMP by using an IMP protocol, and we can connect the each and every host by using one type of host protocol. So each and every host that connected a short wave through the IMP. Okay, so this is an actual diagram. Okay, so IMP stands for Interface Message Processors. The host could send messages of up to 8063 bits to its IMP, which would break them into packets and forward them independently towards the destination. See, this 8063 bits that will be sent to the IMP and break them into packets. Okay, so we are talking about a network. In the network layer, the data, it is in the form of packets. That's why that would be break them into packets and forward them independently. That's why we call as a packet. Okay, towards the destination. The subnet was the first electronic store and forward type packet switch network. So each packet was stored before it is forwarded. Okay, the subnet was the first electronic store and forward. While we are using a subnet means it is a collection of IMPs. So each and every IMP stores the data packet and it will be forward to the switched network. What type of network switched the particular IMP, that will be forwarded to that network. So each packet was stored and then it was forwarded. So this is the actual diagram. You already seen that IMP and host. In 1974, the TCP IP model and protocol were invented specifically to handle communication over internetwork, because more and more networks were getting connected to Arpanet. So For this sake, it handles the communication over the internet network. The TCP IP model that handles the communication over the internet network. In 1980s, so many LANs were connected. Means the people are increasing gradually. So it is very difficult to finding host, and it is very difficult and expensive also. Okay, so DNS was created for organizing missions into domains and map host name into IP address. So in this time, the ARPANET was introduced the DNS concept, domain naming system. I already said in the previous session what is meant by DNS. DNS is one type of protocol that converts the domain name into IP address as well as IP address into domain names. Okay. Here in 1983, the management of ARPANET was handed over the Defense Communications Agency DCA, which separated the military portion into separate milnet. Here the ARPANET was mainly introduced for military bases as well as government communications. In 1983, the ARPANET was handed over the Defense Communication Agency, which separated the military portion into separate milnet. Okay, by 1990, the ARPANET was shut down due to some disease and dismantled. However, milnet continues to operate. This is about an ARPANET. Okay, let us get into the internet. Internet is a global network that connects billions of computers across the world. Billions of computers across the world with each other and to the World Wide Web, WWW. We can call it as WWW. It uses a standard Internet Protocol suite, TCP/IP. From 1990 onwards, the TCP/IP working to the Internet to connect billions of computer users worldwide. Okay, it is set up by using cables such as optical fibers and other wireless and networking technologies. Okay, the internet is also called as network as it's create a network by connecting computers and servers across the world using routers, switches and telephone lines and other communication devices. These are the networking hardware, network hardware. By using this network hardware, we connect different type of computers and servers across the world to make an internet. Okay, and channels. So it can be considered a global network of physical cables such as copper telephone wires, fiber optic cables, TV cables, etc. Okay, let us see the diagram here. The internet works with the help of client and servers. Client means the users. It may be a laptop, desktop, tab, mobile phone, whatever it may be. Servers means the actual network or an internet. The device such as laptop, I already said, is client. But the client is not directly connected to the internet. It indirectly connected through the internet by using an ISP, Internet Service Provider. Listen, the Internet Service Provider is a very, very important thing. Remember this point. The Internet Service Provider means it provides internet services to the client. It provides internet services to the client. Let us see the diagram here. I will show you how indirectly the client connected to the server. See here, this is an actual system. So these are the server. This is a client or this is a server. Okay. In between, we have an ISP. ISP, Internet Service Provider. Okay, we can't directly connect it to the network. We can't directly connect it to the network. We indirectly connected to the network by using an ISP. We connected to the ISP and the ISP connected to the actual server. It provides services. It takes the services from the server and provides that services to a particular user. So what are the examples of ISP? ISP examples means Airtel, BSNL, telephone lines also we have BSNL connection, Act FiberNet, BSNL, Geo. So we also having internet in our mobile phones by using SIMs. So these are the internet service providers. Kindly we can access the network by using that particular service providers. So to access network from the server in between mediator, we can call it as internet service provider. It may be a telephonic lines, it may be a SIMs or whatever it may be. Okay. So this is done. We can't directly connect it to the network or the server. We indirectly connected to the network. That means in the middle we have a concept of ISP, internet service provider, that provide a services to a user. Okay, the server is a large computer that stores the website. It also has an IP address. We know that the server is nothing but it gives an large computer with a number of hard disk. It gives the actual responses what are the request come from the client. So let us go to the diagram how the internet is connected globally. How the internet is connected globally. Documents. See, this is the diagram that internet connected to the globally. So here we have a PC and that PC connected to the router. By that router we are accessing information, that is nothing but on wireless communication, Wi-Fi. Nowadays we are using. See, from that router we are accessing information to laptop as well as tablet as well as PC. Okay. From that, by using an web browser, we are requesting our information to the server. Browsers send a request to the server, and this is the server. See, this is the server. This part is the server. The server provides information in response to the request, and it is connected with an optical fiber which is nothing but an transmission media, and these will be connected to one of the communication device, the router. Okay, so kindly see the whole diagram means we are connecting internet by using different type of network hardware and internet service providers, and for telephone lines we are using a modem. Through the telephone network to access, through the telephone lines to access the network, we use a modem concept here. So modem stands for modulator and demodulator, which is used to convert the digital signals into analog signals as well as analog signals into digital data. Okay, internet service providers. Airtel broadband. See, Airtel broadband means this is the one of the telephone line communication Airtel. Okay, that will be connected by using an optical to the router. So this router will be connected to the server. So this is the whole process of the how internet is connected to the client and client to the server, and in between what are the different type of hardware, network hardware we are using to connect to form a particular internet, particular network. Okay. See, that is the main thing. So types of network we have PAN, LAN, MAN, WAN. So person area network. It is an interconnection of personal technology device to communicate over a short distance which is less than 10 meters. Okay, within 10 meters we can give a network to from one device to another device. Nothing but Bluetooth is an example for person area network. LAN, local area network. In houses and in buildings, we are connecting this local area network. Its range only up to one room or one building. It 10 to 100 Mbps. Suppose 10 to 100 Mbps. Small b means bits. Metropolitan area network, it's a larger network that usually spans several buildings. Means it's a group of, it gives a connection in one city, same city or town. Wide area network, nothing but an several LANs and WANs. I already said WAN is a combination of LANs and WANs. It may be limited to an enterprise or accessible to the public. It covers a large geographical area, which means one country. Example, World Wide Web. World Wide Web. These are the different type of networks we have. Okay, the WAN is nothing but an, we can call it as an internet. And what are the advantages of network here? Internet, instant messaging, online banking, online selling, cloud computing, career building. We can say that internet is also one type of the network. Instant messaging means we can send messages or communicate to anyone using internet. Email or video conferencing, voice chat, WhatsApp. These are the examples of an instant messaging. Online banking. See, online banking statement. For SBI, we have app to see the balance and to receive the money, to transfer the money. We have a phone pay, Google Pay, whatever. This is an online banking. Online selling, we can sell our products. Meesho, Myntra, these are the online selling products. Companies to sell their products. Meesho, Myntra is the companies online to sell online products. Cloud computing. So cloud computing is a very, very important today. The cloud is an act as a database to store our information. Okay, it enables you to connect your computers and internet-enabled devices to cloud services such as the cloud storage or cloud computing, etc. Career building. You can search for jobs online on different job portals and send your CV through email if required. So we can, these are the different type of advantages we have by using the internet. A lot of these only, these not only the advantages, we have a different type of advantages. Okay, by using an internet. Internet is a very, very, it plays a very important role in our day-to-day life. By using internet only, we are doing each and everything, and we can share our data and we can receive the data in time. Okay, so there is no time delay process by using an internet. So in this video we see what is meant by Arpanet and what is the internet and what is the difference. Okay, so kindly like, share and subscribe.